So we already know the LED lights up, and we denote it with V, and the resistor opposes the current, and we denote it with R. The value that we used in the past was 220 ohm, and I have it assembled here. So let's look at it. The cathode, the shorter leg of the LED, goes to ground. Resistor and LED go together, and I have it connected right now with a cable that goes to 3 volts 3. So I will write down my power source, 3 volt 3. Let's think a little bit about this very steady light that we are seeing. The intensity is not changing, and what makes it not breaking is that resistor. So let's think it over. I unplug it for a second. But what would happen if I have 2 resistors instead of 1? So I will connect them in series, and instead of having 220 ohm, I will have 220 ohm and another value. So now I'll put that using 10 kilo ohms right now, but whatever other resistor, and let's see the intensity of the light. And it's dimmer. It's definitely dimmer. Before it was brighter. So let's think about that. I'm adding a resistor. So perhaps one way of seeing it is like, yes, I have a resistor there, and according to our last experiment, the intensity of the light changes. But we have also this one that is a variable resistor. It's a potentiometer that it has a knob here. I didn't say anything about how it works, but we are familiar with them because they live in the volumes of all radios and in the light controls. So we already are familiar with them, but perhaps we have never seen one inside. Let's take it apart to see their physical construction. So I'm taking it into parts. Don't do this at home unless you want to spoil the potentiometer. But this variable resistor, actually it is a resistor. I have it now in my hands. It has 3 terminals, but it's composed of 2 that are connected to a resistor and 1/3 lead, 1/3 plate that touches along the way. So when I turn the knob, the 3rd terminal is selecting how big the resistance is. So the symbol is very similar. There's a resistor, but it also has an arrow to indicate where is the knob pointing. So in my circuit, what I will do is to connect the wire to that 3rd terminal. So the current will flow all the way through the resistor and the diode we had in the past, but now also through this variable resistor or potentiometer. The value for our experiment, it doesn't matter if it's 10K or 100K, but what we want to see is how the intensity of the light changes when I change the resistance. So now I can choose to insert the 3 terminals directly into the breadboard if your model allows you to. Perhaps you have to bend something, especially because the shape of the potentiometer might have been made for something else than inserting it into a breadboard. So I have these female to male connectors, these cables, you just need 2. They don't fit perfectly well, but they do their job. I just inserted them into 2 of the terminals, one of the extremes, it doesn't matter which one, because it's not polarized, and the middle one. So now once I have that, and I connect power, my LED turns when I turn the knob. The intensity is a little bit unstable because the terminals move a little bit, they're a little loose. But actually you can see that it works. Of course, the other option is to connect the potentiometer directly to the breadboard. I think that in my case, it will work as well. Inserting it into the breadboard might be okay for some of you, as I was saying. Then you need to pay attention where are the terminals and to be placing the cables correctly. The range will depend highly on how big is the potentiometer you are using. In my case, it turns quite smoothly, and I chose to use one of 10,000 ohms.